Hello and welcome. In this video we will be looking at question 8 from the 209 booklet, and this topic is on sequences. Okay, so let's look at question 8. The figure below shows the first 3 diagrams in a sequence. Each diagram is made up of dots connected by line segments. In each diagram there are D dots and L line segments. So we have 3 diagrams here in the sequence, and you're required to draw the 4th one on the answer sheet provided, which is the grid looking like this. So let's study the pattern here. So for the first pattern, we see that there is 1 dot in the center. For the second one, there are 2 dots, and it's growing 3. So for the 4th one, you should have 4 dots in the center. But so we could draw the 4th pattern. So let's have a look and see what you should get. You should get something looking like this. Okay, so if you notice, that's 1, then 2 dots in the center, 3 in the center there, and 4 in the center. Now we have a table here now where you are required to complete the table in the rows marked 1 and 2. So let's have a closer look at the table. So the first column there, we have a number of dots, D, and then we have 5 dots in the first diagram. So if we look at the first sequence there, we can see that there are 5 dots. Okay, and we have a rule in the second column here. We have rules connecting L and D. Okay, so the rule is that you're timesing by 2 and subtracting 4. And the third column here, we have the line segments, the number of line segments. So if we should count the dots in the first figure here, we see that there are 5 dots, and the line segments there is 6. Okay, so a segment would be between points. Okay, so this would be 1 line segment, that would be 2. This is classed as 1 line segment as well. So in total we have 6 line segments. But we have a rule that we can use to work out the missing bits here. So we are doubling the dots and subtracting 4. So for this one, all we need to do is to double 62 dots, and then we subtract 4, and then we would get the corresponding line segments. So let's work that out. So in this section here, we should have times by 2. We should have 2 times 62. 2 times 62 minus 4. So that would be 124 minus 4. That's 120. So the rule is that we are timesing by 2 and subtracting 4. Now if they give you the line segments, you need to figure out how many dots should be there. If the rule is that we are timesing by 2 and subtracting 4, all you need to do is to do the reverse operation. So we start with 180 there, and then we do the opposite of minus 4, which is plus 4. Okay, and then after that we actually divide it by 2. We divide whatever we get by 2 there. Okay, so we divide by 2 there. So it would be 180 add 4, and then we divide by 2. So let's write divide by 2 there. So that should be divided by 2. Okay, so if we have 180 here, we add 4, that's 184, and then we divide 184 by 2. That gives us 92. Okay, so that is what we have for that there. Now let's erase this. Can erase that. So we work that out as 92. So now this is very straightforward because we are doubling and then subtracting 4. So for this one, all we need to do is to double 92, right? 2 times 92 minus 4. So we put 2 times 92 minus 4, and that should be in there like that. Okay, that's the rule given. Okay, so we have answered part B. Now let's move on to part C of the question. So in part C, how many dots are in the sixth diagram in the sequence? So the sixth diagram in the sequence has to do with the position of the diagram in each sequence. So it's a sixth position. So this will be the first position, second, third, fourth, fifth, sixth, and so on. So this part of the question is different from the rule that is given here, because this rule was the pattern connecting the line segments and the dots, but this one is just dots only. So let's look at the rule here for the dots. We see that we have 5 and then 8 and then 11. So for the first we have 5 dots, for the second we have 8, and for the third we have 11. So part C, we have so we have 5, then we have 8, then we have 11. So the rule is that we're adding 3. Okay, we're adding 3. So it means that we can write the nth term for it. So we would have 3n plus, this is 3 times table, and it's bigger by 2, so we plus 2. So to work out how many dots are in the 6 pattern, 6 here has to do with the position of the number n. So this is n1 when n is 1, when n is 2, n is 3, n is 4. So we want to find out how many dots would be when we're at the 6. So it would be 3 times 6 plus 2. So that gives us 20. So there would be 20 dots in the 6 pattern. Now part 2, so this is part 1. Okay, part 2 of C now. How many line segments are in the 7th diagram in the sequence? So the 7th diagram, so let's look at the formula for the line segment. For the line segment we have 6, then 12, then 18. 6, 12, and 18. So we realize that it's going up by 6. Alright, we're adding 6 every time. And you can see that it's a 6 times table, so the nth term for it is going to be 6n. So n here has to do with the position. So the 7th position would be 6 times 7. So 42. Okay, now it says that write the rule which shows how L and D are related. Previously, we know that the rule for line segment, we can write that line segment L is equal to 2 times D, 2D, 2 times D minus 4, right? So this was a formula for the line segment here. We can do a test. So for example, for when we have 8 dots, we would have 2 times 8, which is 16, subtract 4, that gives us 12. So all we need to do is to rearrange this formula to get the dots. So part 3, we know that L, let's write this. We know that L equals to, I'll write it out and rearrange it for D. We know that L equals to 2D minus 4. So if we want to get a formula connecting how D and L are related, then we would just have make these the subject of the formula. So we add 4 both sides there. So it means that we would have L plus 4. We would have 2D there, okay? And we divide both sides by 2. So D equals to L plus 4 over 2. right? So it's the same formula, you just rearrange it to make D the subject. If you do this, you'd still get the mark for it, okay? Here ends question 8.